All right, today we're jumping right into something huge, the architecture of inquiry. Basically, how do we even begin to ask questions and build the knowledge that, shapes our entire world? It really boils down to this one fundamental question, a question that powers everything from deep philosophy to cutting-edge science. How do we actually build what we know? So you probably have this image in your head, right? That we build knowledge like a bricklayer builds a wall, just carefully stacking one proven fact on top of another. Solid, secure. But what if that whole idea is just wrong?
Yeah, the reality is it's way more creative and honestly a lot more uncertain than just laying bricks. It's much more like sketching a map.
A map for a land we have never ever explored. Think about it. We're just catching these little glimpses of the shoreline. And from that, we have to draw this whole sketch. And then we use that very sketch to guide us as we venture into the unknown. Okay, so if we're making a map, how do we draw that first line? This gets us to a really key idea, what we'll call the bridge of inquiry. See, to get from a question to a real answer, you first need a testable answer, or maybe a working answer. And that bridge, that's the hypothesis. And look, a hypothesis is not some boring, rigid statement you memorize in science class. No way. It's a disciplined act of imagination. It's this creative and, this is super important, a tentative first step towards an answer. It's built to be challenged, to be poked and prodded and refined. So there are really two main ways we go about building these bridges. Let's start in the world of pure ideas, in what you could call the philosophical workshop. This is where we craft and shape ideas using the tools of pure logic. Now, take a look at this. The first thing you should notice is that this is not a straight line. It's a loop. A philosopher asks a big question, they craft a possible answer, and then, get this, they immediately try to destroy it. They look for problems, for counterexamples, and when they find a crack in the idea, they don't just throw it away. Nope, they fix it, amend it, and start the whole process over again, getting a little bit closer to the truth with every single loop. The main tool they use for this is something called conceptual analysis. It sounds complicated, but it's really just about trying to nail down the essential ingredients of a concept. Like, what are the absolute necessary and sufficient conditions for something to count as knowledge, and not just, a lucky guess? It's about finding the core definition. All right, let's switch gears and move to our second path. We're leaving the abstract workshop and heading out into the real empirical world. We're trading our logic tools for a scientific compass to guide our exploration with actual data. And check out step 1 here. It's so important. The source material actually calls this scientific invention. It starts with imagination. It's a creative leap of faith to form a hypothesis. Only then do you move on to deducing a prediction from it that you can actually go out and test in the real world. And this brings our analogy home perfectly. A scientific hypothesis isn't the treasure you dig up at the end of the quest. It's the compass you build before you even start the journey. It's the tool that tells you where to point your shovel, what to even look for in this huge, messy wilderness of data. Science has this really clever trick to keep itself honest. It's called the null hypothesis. Basically, it's the default assumption that your cool new idea is wrong, that there's no effect, no relationship, nothing to see here. The scientist's entire job is to gather enough evidence to prove that default assumption wrong. This whole process guarantees that every claim is falsifiable, that there's a clear way to show it's incorrect if it actually is. Okay, this all sounds great, but what happens when the evidence is, messy? When your data could point to multiple, even contradictory explanations? This is where things get really interesting. We have to figure out how to choose the best map when the evidence alone just isn't cutting it. This exact problem has a name. It's called underdetermination. And it's a fascinating and actually pretty common situation where you can have two or more totally different maps, totally different hypotheses that both perfectly explain all the data you've seen so far. So let's go back to our map. Imagine you have two different maps, and both of them perfectly match the coastline you can see with your own eyes. Which one do you trust for the journey inland? The data, the coastline, can't help you decide. So what do? Well, you have to judge the maps themselves. You use a set of criteria that aren't based on the data, called theoretic virtues. You ask questions like, is one map simpler? Occam's razor? The one with fewer weird sea monsters drawn in the margins? Is one more testable? How about fruitful? Does one of them suggest all sorts of new, exciting places to explore? And finally,
Is it conservative? Does it fit well with all the other maps we already trust? We basically choose the hypothesis that has the most of these virtues.
And all of this brings us to a really profound final point about this whole process. We're talking about the never-ending journey and why the method we use to create our maps is, in the end, way more important than any single map we create. So here's the absolute crucial takeaway. We never, ever arrive at the final answer. A hypothesis, whether it's in science or philosophy, is simply the best working answer we have right now. It's the best possible map we can draw with the information and the tools we have at this very moment. This entire way of thinking is built on a really powerful philosophical principle called fallibilism. It's this humble but incredibly honest idea that any of our beliefs, any of our beautiful maps, no matter how well supported they seem, could turn out to be wrong as we explore more. And that's not a weakness. That's the core strength of the entire system. Which brings us to what might be the single most important line in this whole explainer. Within any kind of rational inquiry, the goal isn't just to get an answer. The real goal is to perfect the method of getting answers. The process itself is more important than any one product. And our analogy just illustrates this perfectly. Think about it. When your journey reveals a huge mountain right where your map showed a valley, you haven't failed. You've actually succeeded. You don't just crumple up the map and give up on map making altogether. Of course not. You pull out your pencil, you erase the valley, and you amend the sketch. You make a better map. And so, I want to leave you with this final thought. If we accept that every answer we find is temporary, that every map we create is just a working sketch that's destined to be revised, then what's the true purpose of this journey of inquiry anyway?